We're going to look at derivative of trig functions. So back in section 3.2, I calculated the derivative of the sine. And to do that, I used the limit of the difference quotient. So the limit of h goes to 0 of the sine of x plus h minus the sine of x, all divided by h. And I went through all the steps on how to do that. It was pretty complicated. We had to do a couple of limits. And so that took like, I don't know, 15, 20 minutes to figure that out. We ended up with the cosine of x. Now I'm not going to repeat that. It's in a video in YouTube and it's in my notes, in the notes pages. So we have that one right there. Bottom line is, how do you know what a derivative is? Well, you have to take the limit of the difference quotient or use some other rule we've already proved. So the next thing we got to do is check out, well, what's the derivative of the cosine? And then once we have the derivative of the cosine, since all the other trig functions can be written as sines and cosines, I don't need to do any more limits. We can just use other rules. So I'm going to go through the derivative of the cosine proof. And it's partly based on the derivative of the sine. So that means I need to find the limit as h goes to 0 of the cosine of x plus h minus the cosine of x, all divided by h. Now, if you just took trig last quarter, then you might remember the angle sum rule for cosine. Otherwise, you got to look it up. And so I haven't taught trig in a while. I think I remember it, but I'm going to look it up just to double check. So trig identities, it's also in the book. At the end, there's an appendix. And let's go purple math. Cool, I love purple. All right, so I want the angle sum rule for cosine right here. So it says cosine of the sum of two angles is cosine cosine minus sine sine. All right, not bad. So I can expand this right here, and I've got to do that because right now if I just cheat and plug in 0, I get 0 over 0, which doesn't tell me anything. So now I have the limit as h goes to 0 of the cosine of x times the cosine of h minus the sine of x times the sine of h minus the cosine of x, all divided by h. All right, so then I got to do some algebraic trickery here. And what I noticed at first glance is there is a cosine of x here and a cosine of x here. So I can factor that out of these two terms right there. So I'm going to put those two together. So limit as h goes to 0. So if I factor the cosine from here, that's going to leave the cosine of h behind. And if I factor the cosine from here, that's going to leave a -1 behind. And then I have this negative sine of x times the sine of h hanging out. And all of this is divided by h. So what I'm going to do is I'm going to break this fraction apart on the subtraction and say this is divided by h and that is divided by h. And now I want the limit of all of this. When I did the proof of the sine here, I had to figure out what was this limit as h goes to 0, and I had to figure out what this one was as h goes to 0. The second one was the harder of the two. I had to use the unit circle and a bit of geometry to prove it. But what we ended up finding when we did that geometry is we found that that limit right there goes to 1. For this one right here, I had to multiply top and bottom by the cosine of h plus 1, which is like a conjugate. And after playing around with that one a week or so ago, I found that this one right here went to 0. And so if you're curious about that, just send me a note and I can show you the link in the YouTube video, but it was when we were covering section 3.2 on the second day of that. So if that goes to 0, well, there's no h here, so I get cosine of x times 0. And then here I get minus sine of x times 1. cleaning that up, that means the derivative of the cosine is the opposite of the sine of x. So since we've just proved this, we don't have to use the limit definition anymore. Anytime we see a sine, we can just say, oh, the derivative is cosine. And anytime we say the derivative of cosine, we can just say, oh, the derivative is the negative sine of x, right? We proved it. We're done with that proof. Let's move on to some other functions. And I'm going to have you help me with some of them. So next most popular trig function is the tangent. So I want to know what's the derivative of the tangent. Oops, not t, use x. And to do that, I'm not going to use the limit definition. I'm just going to use that the tangent is sine over cosine. And then I can apply the quotient rule here. So the quotient rule says, take the derivative of the top, and from the previous work we did, we know the derivative of the sine of x is the cosine of x. And then multiply by the bottom. Well, that's another cosine of x. Minus, leave the top alone, and take the derivative of the bottom. Derivative of the bottom is the negative cosine of x. And I need to put that in parentheses to make it clear that I'm multiplying by a negative, I'm not subtracting. All divided by the square of the bottom, which is the cosine squared of x. The numerator is wicked cool, because that becomes cosine squared of x plus sine squared of x. And what do we know about that? Can you tell me about the numerator? Hopefully somebody says that looks familiar. That is equal to what? I know one of you knows this. Please speak up or put it in the chat. Uh-oh, you guys are scaring me. Cosine squared plus sine squared. This is the Pythagorean identity, the most famous trig identity ever. What is it equal to? Oh, thank you so much. It's 1, yes, Pythagorean identity for trig. Cosine squared plus sine squared is 1. This gives me 1 over the cosine squared of x, which I can also write as 1 over the cosine of x squared. Now, does anybody remember, reaching way back to your trigonometric memory, there's another function that is equal to 1 over cosine of x. What function is it? Is it the tangent? Is it the secant? Or is it the cosecant? 1 over cosine is equal to the cosecant. Almost. It's the secant. Good guess, though. Yeah. So it turns out it's the secant. We could prove that geometrically, but I'm just going to go with it. So this is the secant, and it is squared. Oops, forgot my square up there. Secant squared. So the derivative of the tangent is the secant squared. And it turns out all the trig functions, we can just whip out something like this. So I'm going to do one more, and then we're just about out of time. Derivative of the, let's do the secant since we have it right there. So we've got sine covered, cosine covered, tangents done, secant, and then we're going to do cosecant. So the derivative of the secant. To do that, I'm going to rewrite it as a cosine. So that is the derivative with respect to x of 1 over the cosine of x. And now I have a quotient, so I can use the quotient rule. Quotient rule says take the derivative of the numerator first. Derivative of 1 is 0 times the bottom function, cosine. Minus, leave the top function alone, 1 times the derivative of the bottom. Derivative of the cosine is the negative sine. All divided by cosine squared. All right, so cleaning this up, 0 times cosine is 0. Negative 1 times negative sine is sine. So I get the sine of x over the cosine squared. And it turns out we can use way less ink to write this down. So let's see, what are we going to do? Well, I see a sine over cosine, and when I see sine over cosine, I think tangent. So I'm going to write this as sine of x over cosine of x times cosine of x. Because I can call this one here the tangent, and then what do I call 1 over cosine? We just realized that that's the secant, so this can be rewritten as the tangent of x times the secant of x, sorry. And usually it's written in alphabetical order, so it's usually written as secant tangent. But either way works. All right, that was fun, that was exciting. And we're just about out of time, so I'm just going to summarize what we know. Trig derivatives. So the purpose, most of this chapter is half of the time we're using the limit of the difference quotient to get us started, but then we're working on derivatives we already know. So we're going to do less and less limits as we move on here, which I'm sure some of you are very happy about because limits are kind of a pain sometimes, but that's part of calculus. Calculus is the study of infinity. So we have the derivative of the sine of x is the cosine of x. We have the derivative of the cosine of x is equal to the opposite of the sine of x. We have the derivative of the tangent is the secant squared of x. Now we have the derivative of the secant is the secant times the tangent. So we just need 2 more to finish this up. Derivative with respect to x of the cotangent, and the derivative with respect to x of the cosecant of x. And it turns out they are pretty similar to these other ones here. So I'm just going to state them and not worry about proving them. Proving them is exactly the same steps as we went through for these 2 here. The cotangent is the negative cosecant squared of x. Okay? So tangent, secant squared, cotangent, negative cosecant squared. See the kind of mirror images going on there? Cosecant is kind of similar to this one right there. Because it is a co-function, it is a negative. All the cos have a negative result. And instead of a secant, it's a cosecant. And instead of a tangent, it is a cotangent of x. So there's a definite pattern going on with these last 4 there. And so the homework is about using these along with other functions and the product rule and the quotient rule. So you're just going to mainly get some practice with the product rule, quotient rule, and applying these results right here and doing a wee bit of algebra. So remember, try to simplify each one as much as possible. If you're not sure if your answer is simplified, hit the message me button and say, hey, this is my answer. Is it the most simplified answer? And I will gladly get back to you and try to help you figure that out. Sometimes it's easy and sometimes it's not. But part of calculus is getting better at algebra. All right, we are out of time for fun with math today. Thank you for playing with me. It was good to see you all. Do good math, and I will see you tomorrow.